As usual, copy and paste the content of the setup SQL file into a new SQL worksheet in the Snowflake UI. I just created this database, test database, with a customers table. As you can see here, we have a name and a country. And right now, I just created a few insert statements, some of them with one, two, or three different entries each. So right now, for about 10 minutes, I will just select a bunch of them, Control Enter to just execute the queries. Yeah, as you can see here, okay, so they will be inserted. I just pick up some other queries just to make it easier for the test case that we have here. So I will continue to do this for the next 8 or 9 minutes. Try to do the same. We're not concerned here at all with duplicates. We're concerned with the total number of entries. So I will do this, and as you can see at the end, uh, try to populate this with around 100 entries, just to have something to look at. If you see, for now, this is what we have, but continue and spread them rather equally over the next few minutes. Okay, so I'll be back. Okay, guys, I have here 120 entries. You can see them on screen, nothing special. But how to get right now any daytime related information? Because as far as I know, there is no timestamp associated, accessible timestamp that I can access associated to a table row. Let's start by looking at the table itself. When you say show tables, okay, this will show me the tables from this specific database. So here is our table. You can see when it was created, and if you can, if you can go here, you see this retention time 1. This means that our table is using time travel. Time travel in Snowflake is a very important feature. Learn more about it by looking here, but basically, uh, table operations will keep additional data for a limited time. In this case, whether or not you are in standard edition or in enterprise edition, by default, you have 1 day time travel for any permanent table, like this one, like the table of customers. So, in this case, we can go back and look at data that this table has. We can go back 1 day maximum. To do this, we can do this in different ways, but have a look at this. Our table was created at this time. Yeah, that's a local time zone timestamp. So just copy it, and going back here, let's see. I want the number of customers, but when? But you can say this, and that's an absolute timestamp, and we can pass this value. But here we'll have to say timestamp LTZ because it's a local time zone daytime here. So there are variations with an offset, yeah, with a relative time. You can look back a relative number of hours, let's say, or by statement ID. But in our case, we'll use this that's absolute time. And that's a variation with a ton before, but we'll use that. If we use that, okay, we'll get this first of all. Time travel date is not available to table customers. Why this? Because we looked at the table creation time. So if we increase our time with, let's say, just 1 second, okay, we can see that the count was 0. 1 second later, we didn't populate anything in the table. If we look later on here, let's say instead of 7, I will pass 14. Okay, we can see that a few minutes later, yes, I had 8. I had 8 rows in this table. So you basically look back in time at a slice of what your table looked at the specific time. So right now, yeah, definitely we should generate. If we want this for 10 minutes, we need a generator for 1, 2, 3, 4, yeah, a sequence of 10 numbers. So in this case, you can see I generated 10 rows, and we should be basically able to do something like this to combine what the generator returns to us, the 10 rows, with extracting the count, yeah, from customer at different timestamps. But if we run this, you'll see that yeah, we don't get the expected results. Definitely here, try it. I played with this, but I found out that actually I cannot pass in the timestamp as a parameter here something like a function. But because we have a limited number of rows here, just 10, we can use a select union all. And look, what I did here, I repeated the same select count, yeah, from customer with a step number in front at different timestamps. So I increase this with 1 minute, yeah, gradually. If I run this one in here, this is what we'll get. Yeah. So, but right now, as you see here, we want not the number of rows at that moment, but we want the difference to return for each row the difference of the total number of rows added at this specific minute. I separated the CTE in here, and as you can see later on, and I use a step total, yeah, the way it comes from here, but I use a lag to look back one records, and I subtract this lag from the total record. So this gives me actually what I was looking for. Let's run it. Okay, you can see the difference here. The difference is acceptable, and right now I want a chart with this. Go here, and I would like a bar chart. Absolutely. And I don't want the total number, and definitely I don't want it in descending order. I want it in ascending order, and just replace total with, as you can see here, with the diff. And here you have it, guys. This is how the distribution of the values I added over those 10 minutes looks like. What if we didn't use time travel, or let's say I populated this table more than 1 day before, so time travel is no longer available, or the time travel was simply disabled, or what if we won all this for more than 10 minutes? As you see with the union query, is very difficult to do it. Okay, so let's do it in a different way because, as you can see here, Snowflake is permanently auditing all the queries that you may run, you or any other user. If you filter, automatically it's filtered by your username here, but you can say, let's say, statement type here, and you can select just inserts. If you apply the filter here, oh, you can discover that we have basically all our insert into customers statements in here. To do this programmatically, yeah, definitely we can query what is called. You see, I will simply copy and paste it from here. We can use a table function from the information schema. So there is no latency here. We get the result right away. It's called query history. And here, yeah, definitely we should pass some parameters. I already separated this timestamp. The creation type, the creation time of our query. So I will say at T0, I will say current timestamp. Okay. Okay, and by default, this will select only 100 entries, but you can go up to 10,000. So we want everything in here, and yeah, let's see what we get. Okay, so this is good, but as you can see, definitely we have a mix up of different query types here. If you go in here, you can select the database name, schema name. Let's limit all this, and we'll limit with the query type just inserts. And what else can we have here? Yeah, we can use username, but for now, I know that I'm the only one who used this account. Yeah, so definitely you can use yeah, execution status, success, and so on. So I will apply this filter. Okay, this looks like a better query, and if you look into the query text, definitely will have only insert for successful queries. Just like we did before using lag, we'll use the same trick here. You see, just to get the difference, because yeah, this is important. You've seen before, row produced in the query history function. Row produced shows actually the total count of the rows in the table at that moment when we inserted records. So just to get the number of rows actually inserted by a query, we'll have to look back with lag and subtract the lag from the total number of rows. So let's run this. We'll have one more thing to do because the step here, as you can see, is not unique. So we'll have to group by. This is the minute. So we'll have to group by and sum the numbers of rows inserted by minute. Okay, just like before, let's get a chart with this, and we'll use the same a bar chart. Make sure, okay, this should be ascending by the minute, and in here, yeah, definitely that's a difference, and this is a distribution.